Not that I was, man.
You were.
Here you go. I want to start as soon as possible. We're going to start on the back page because that was your homework.
Somebody got a haircut.
That's right.
You get a fade.
For you. Quiz tomorrow.
Quiz tomorrow?
Oh, I'm leaving at 2. Mr. Mac.
Guys, when the bell rings, you're done writing.
Mr. Mac, I'm leaving at 2
See you, Mac. Rad.
on this class.
That sucks.
Yeah.
My life is Poe.
I'm just telling you so you know.
Over there. Here you go. Parker's.
Oh, yeah.
Hey, is your life Poe?
What?
Are you ready?
McKenna's dad.
Max, what's your last name?
Clemson.
Clemson.
That's what
No, it's Max's last name.
Who's Max?
You don't know Max Clemson?
That's Max.
Yes.
I got football to the max.
No.
Why is Max?
Type in your thing.
Get out of here, Max.
All right, this is for you. When the bell rings, you're done.
Those were like
There you go. Hey. Hey.
All right, you got
It's
it?
right there. Yep.
You got it.
There you go.
Clemson. There we go.
Have fun.
I'm following it.
All right.
Boys, I got. Boys, get to be
Stop
the boys.
picking on Parker. You big bully.
Well, let me follow it.
Let the power of Christ fill you. There you go. Just wanna.
Do you have a pencil?
Pencil? No way.
Olivia.
Jesus, the guy. Any pen you want, though. As long as it's not from this bin.
That's like when you're so anxious later.
All right, sit down. It's time to go. All right, your homework yesterday. Nope, no more. Let's go. And if you see dumb stuff up there, please erase it. No.
Chelsea.
Oh, close the door, yes. All right, so here's the deal. We're going to start at the back because that was your homework. Deriving the formula, the quadratic formula. So we're on number 14. Oh, yeah. So here we go. First, we're going to start out in standard form. Remember, the quadratic formula helps you find out what the x's are, the x-intercepts, right? So where y is 0.
I did not get it.
Let's go, let's go. So when y is 0, what does x have to be is what we're trying to figure out.
That's a good question.
There is a formula for that. Now, figuring it out without the formula is very tough. We're going to learn how to do that. But sometimes it won't be nice numbers. And so this is the thing we use to do that. Okay? We're going to derive that formula. We're going to come up with it. So the first thing we're going to do is we're going to complete the square, right? Which we've been doing. And then we're going to move stuff around to get x on its own. That's the idea. And once x on its own, we know that's what x must equal when y is 0. Cool? So here we go. I'll erase it all if you can't focus. So first things first. Normally we don't really mess with this thing. It kind of sticks out on the side and we ignore it for completing the square, right? What I'm going to do is I'm going to move that over. Because I know I don't mess with it for completing the square, right? I just ignore it. I'm going to move it over so it's completely out of my way. So first things first is this. Cool with that? Lindsay, I'm sorry. It's been a while. I can help though.
She's not dead, is
I'm very happy she's alive. I was concerned. All right, so now we're going to complete the square. You know how to do it.
You got a haircut.
I did. So first I'm going to pull out the a, right? When I pull it out from ax squared, I get x squared. When I pull it out from bx, I get what?
ABX.
B over ax. Right? It's kind of like division. Right? If I were to put it back, would that get rid of the a in the bottom? Yes. Right? We would be able to go backwards. Okay? So I pulled out the a. Now we're going to complete the square. So we have x squared plus whatever b over a is. Now normally that'd just be a number, right? That would simplify to some number or fraction, right? what we have to do is cut that rectangle in half, right? And then add that squared. So what is half of b over a?
1/2 over
Yep. 1/2 b over a, or b over 2a, right? Does that make sense? And we're adding that squared. Make sure you wrap that in parentheses so you know you square the whole thing, not just b squared, right? We want b to be squared and the 2a to be squared. Right, whole thing squared. Now we added something to our equation, so we got to add it to both sides, right? We can't just throw stuff on there, right? Now what do we add? We added b squared over 4a squared, and the reason for that is this. B squared over 2a, all that means is b over 2a times b over 2a, right? The number times itself. Now what is b over 2a times itself?
B over
B squared in the top
4a.
and 4a squared in the bottom, right? 2a times 2a is 4a squared. 2 times 2 is 4, a times a is a squared. You with me on that? So that's what we really added. However, don't forget about the a, right? That's going to multiply with this. So if I have b squared over 4a squared, and I multiply that by this a in front, that'll show me what I really added, right? Well, that'll be this. B squared over 4a. 2 a's in the bottom, 1 in the top. 1 cancels, right? A over a is 1, and the other a is left over. Are we cool with that? So that's what I really added. So I'm going to add that to this side. So all we're doing is completing the square right now. That's it. We cut that number in half, added it squared, and we added that to the same side. Okay? This is the simplified version. This is with the square in it. Okay? So when we complete the square, the reason we do that is so that this becomes a perfect square. A square with these dimensions. X plus b over 2a, quantity squared. That's what that becomes. It all shrinks down to that. Right? This completes a perfect square. And the sides of that square will be x plus b over 2a each, right? So the area of that would be this. There's still an a in front of there. Now here's what I'm going to do. I'm going to get common denominators over here first. So what I'm going to multiply by is I'm going to multiply by 4a to the top and bottom. So I get this Does everybody see how I got from negative c to this? I multiplied 4a to the top and the bottom. And that's the same as 4a divided by 4a. And what's 4a divided by 4a? 1. So I multiplied by 1. Doesn't change anything, right? Just makes it look different. And now I've got common denomi, so I can put it together. Yes, Jace?
So times it by 4a, so we could just get common denominator.
Yeah, I knew I needed common denominators, so I needed 4a in the bottom. And I can't just divide by 4a randomly, right? I want to divide and multiply by 4a, so it's the same as timesing by 1. Doesn't change anything. Are we cool with that idea? Anna, you feeling okay? All right. And now if they're common denominators, I can put them all under the same denominator. So I've got this. I'm going to write the b squared first because it's all just minus, right? Okay. I just wrote the b squared first and the minus 4a second. 4ac. Now remember, our whole goal is to get x on its own, right? So what we're going to do is move the a over first. So how do I separate the a from this? Divide, because it's multiplication going on there, right? So when I divide, doesn't that just put the another a on the bottom? Right? So all it's going to be is this, b squared minus 4ac all over 4a squared. Right? When we divide, it's just multiplication done on the bottom, right? Yep. There's already 4a there, and when we divide by a, we're really timesing by a on the bottom, right? Multiplication. Division is just multiplication done on the bottom, right? That's all division is, right? So when we divide by a, we're really multiplying to the bottom. That's all. Okay. And now x is close to being on its own. What do we have to do to get inside here? Nope, not subtract. We got to get rid of this first, right? We got to root everything so we can get inside, right? So when we root this, we just get what's inside, because roots and squares cancel, right? So now it's out of there. This side we have to root. So the whole thing gets under the root. And this is good, because we're almost done. We almost have x on its own. All we got to do is subtract that over, right? Here's what I'm going to do first before I subtract that. I'm going to clean this up a little bit, okay? The top, we got two terms here, right, in the top. Do not root them individually. You cannot do that. It does not work. I swear it doesn't, okay? Trust me. So you just got to leave it like this. But in the bottom, we can root that. What's the root of 4? And what's the root of a squared? So that just becomes 2a. We rooted the bottom but not the top, right? Top we don't touch because it's two terms. Bottom is one term, and it works out nicely. So let's do it. And what do you notice? We already have our common denominators, right? So when we move it over, we can put them together. How am I going to move that over? Again, when we move stuff, it's either addition or subtraction. I'm moving the whole thing. I'm going to subtract it. So I'm going to write it like this. I'm going to put this all over 2a. So I'm just moving that b over. Negative b, square root of b squared minus 4ac is already there. They were already common denominators. So I just put the minus b on top because I'm subtracting it, right? Does everybody see how they had common denominators so I can put them together?
So the 2a's cancel.
They don't cancel. They're the same denominators. If I have 3/4 minus 1/4, I get 2/4, right? Because they have the same denominators. When I subtract b over 2a, since this is over 2a, they're both over 2a. Okay? They're common denominators. So it's just this guy minus that guy on top. Now, I wrote the negative b out front because when we take a root, that means what number times itself gets me the thing inside, right? So if I have the root of 36, what's the root of 36? 6 or negative 6, because both of those numbers times themselves give me 36. So this can be a plus or a minus. Technically, we've had that all the time. So you take negative b, and you add it to root of b squared minus 4 over ac and divide by 2a. That's one of your answers. And the other answer is you take negative b, and you subtract the square root of b squared minus 4 over 4ac over 2a. You get two different answers, and that makes sense. Because what does this find us? It finds us the two spots where y is 0, right? So we should have two answers. We should. It's okay. So that's the quadratic formula. Now where do a, b, and c come from? Well, they come from this. If you take the first number here, the number there, and the number there, and plug them into this formula, ding, it pops out your two x-intercepts. They tell you what x is and y is 0. Now, these numbers might always be a nice number, right? Here on this, it looks like it's 2 and negative 2, right? But couldn't it also be like a really weird number, like anywhere in between, right? That's why this is gross looking. When the numbers are nice, it'll pop out a nice number. And when the numbers aren't, it'll be awful. Yeah, you can go. So what did we do? First, nice shot.
God, he's a back.
Sign out, Ethan.
No, he's good. First, we completed the square. Does everybody see that? First, we got to vertex form, completing the square. After we completed the square, we just got common denominators, right? Right? We just got common denominators. And then we got x on its own. I'll say it again. This is a lot of writing, but we did three things. First, we completed the square, right? We got to vertex form. You know how to do that. It's kind of gross. There's some weird things you got to remember, right? Got to remember the a, got to think about what this means, right? Do it to both sides. But we completed the square. Then we got common denominators for these two. And I ended up here, right? Then I got x on its own. Get rid of the a, get rid of the square, get rid of the b over 2a. That's what we get. I'll say it one more time. First, we completed the square. And we got to here, right? First, we completed the square. Then, I got common denominators here, right? They both need to be over 4a. So I did that. Then I got x on its own. Get rid of the a, get rid of the square, get rid of the b over 2a. And that's what comes out. The further you get, the more points you'll get. We completed the square. We got common denominators. And then we got x on its own.
Can we finally show them the real a circle becoming a rectangle?
Someday.
Someday.
All right, let's go back to number 1. Get each of these equations in standard form. What is standard form? ax squared plus bx plus c equals y. That's what form we need to get it in, right? So it's already close. Just get y on its own, right? Pretty much. So let's move over. Like, a lot of you guys are going to be like, oh, fraction, let's multiply. No, no. Just move the whole thing over, right? So when we move that over, don't we add? There's already an x squared there, and I'm adding on a fifth of x. Now, how do I get y on its own?
Divide by 2.
Divide everything by 2. So this becomes y. What does x squared divided by 2 get us? A half of x squared, right? Or you can do x squared over 2. I'll accept that. I like it with a out front instead of having it on the bottom. That's better. What's a fifth divided by 2?
1/10.
A tenth, right? Isn't division just multiplication on the bottom?
Yes. Good job, James.
Way big brain kid.
Right. A fifth cut in 2. A tenth. Right? What's a half cut in 2? A fourth.
Don't call it the square pizza again.
That's right. We're done. 2. Let's get y on its own, and then we got to get it to look like standard form, right? But I'm going to get y on its own first. Let's move over the 9.
Done.
Can I subtract that 9 from the 3? What do I get? -6. All right. What form is that in?
Vertex.
It's vertex form, right? What does it mean to square something?
Multiply by itself.
So in order to expand this, what I'm going to do is I'm going to write that as x minus 5 times the quantity of x minus 5. Now, how do we mess with this? If I just had this, what would you do with the -5? What would you do? We're going to distribute, right? And then we're going to distribute the x. That's it. So let's distribute the x first. What's x times x? 2x. So we have y equals 2 times whatever all this junk ends up being, right? And then -6. So x times x is not 2x, but
X squared.
x squared. Well, something times something, right? Something times itself is squared, right? 3 times 3 is 3 squared, right? X times x is x squared. No. So you'll see. Okay. X times -5, right? We're going to distribute that. What's x times -5? Minus 5x, right? -5x. If it was 5 times x, you'd be like 5x, right? It's -5 times x, -5x. All right, now we got to distribute the -5. Yeah, go. What's -5 times x? -5x. Don't forget the minus sign. We're going to combine those later, aren't we? Right?
Yes.
What's -5 times -5?
-25.
Try again.
Oh, positive.
Yep. Cool. And again, that's still inside the parentheses, right? We got to multiply it by 2 later, and we got to subtract 6 later. Don't forget those parentheses are still there. You see how that expanded it?
Yeah.
Like, so Caden, see how we have 4 terms now? Right? So it kind of expanded it. That's what we call that. Okay? Before we only had 2. And I slowly worked to have 4. So now what are we going to do with that 2? Distribute, right? I'm going to do this all in one go. That's 2x squared. What's -5x and -5x put together? Taking away 5 and take away 5 more, it's the same as just taking away 10, right? So it's -10x, but I double it. What's double of 25? 50. Oh, and then I have to -6 later, right? So what's 50 minus 6? 44. Standard form, A, B, and C. You could plug that into your formula and find the zeros.
Yay.
Yay! 3. Isn't it the same dumb thing? It's just there's a negative in front of the y. Okay, do the same thing, but then move the negative over when you're done. How do you move a negative over?
Just multiply by it.
Divide by -1 or times by -1. Either way, right? Right. Or if you really want, move everything. I don't know. I would just save that for the last. Right? Do all the thing and then move it. I'll save you that one to do as homework if you want. It's not homework, but it's like for exercise for practice, right?
We never have homework.
Number 4. Isn't this one just the last one we did, but it's already got it easier for us?
Yes.
That's convenient. Do the thing and then move over the 1. Great. Number 5. Isn't this the same thing, but we just got to do more? Let's do this one together. Here's what I'm going to do. I want this expanded. That's standard form, right? So I'm going to distribute the 2 and get 2y plus 2, and then a minus 3. Over here, x squared. Let's do this in our heads. We're going to add on whatever this is. What's x times x? Add another x squared. What's x times 4? 4x. All right, we distributed the x. Boop, boop. Let's distribute the negative 4. What's negative 4 times x? Negative 4x. Those are going to go away, aren't they? Whoa! When the signs are opposite, they go away. All right, so negative 4 times positive 4 is what? Okay, and now we just move things, right, and get them together, right? Terrible idea in life, great idea in math. Let's get our x's together. Plus 2 minus 3, that's just minus 1, right? 2x squareds, that's 2x. It kind of makes sense, doesn't it? Right? I have 2x squared, so I have 2x squared. It's like why they call it that. And then this is 0, right? So minus 16. Now, we can divide by 2 to everything, or we can add 1 first. It's up to you. Doesn't matter. I'm going to add 1 first. Yay! This one has what? Okay, so in this one in standard form, a is the number in front of x squared, right? So a would be 1. What's b? A is 1 in the standard form. What must b be? 0, right? 0 times x. It's gone. And then c is minus 15 halves. It's gross, but who cares? It happens. Number 6 is the same dumb crap. It is. You'll get your x's together. You'll have common denominators you need to get. You don't like fractions? Multiply everything by 2. Seven. It's in standard form. A is 1, B is 4, and C must be 0. We're going to get it in vertex form, completing the square. Let's practice. This one's an easier one. What? You will for an explanation, but not now. You can if it helps you, right? Is there an a value that isn't 1 here? No, right? So we don't need to pull anything out. All we do is cut the rectangle in half, right? What's the rectangle cut in half? 2, right? So we add on 2 squared. We got to do it to both sides. Don't you love it when a is 1?
Yeah.
You really have to.
It won't be. Oh yeah, what does this become? This is a perfect square, so what do I write that as? X plus 2 quantity squared, right?
Wait, is that a square or is that?
Nope, this is a thingy. I made a mistake. Right, all of that becomes this. That's why we added it on, right, to make it that. Yes? Yes, so so we have x squared, right? That's x by x, right? And then we have half of the rectangle here and here. 2 by x, right? You see what I'm saying? I'll show you in a second. So x, right? This is x squared, right? That's x by x. I'm adding on a rectangle of 4x. I cut it into 2 rectangles of 2x, right? And then I added on 2 squared. How did I know I needed to add on 2 squared? Because the dimensions of that square that I'm missing is 2 by 2, 2 squared. Now, what does this become? It becomes a square that's x plus 2 by x plus 2, otherwise known as x plus 2 squared. Do you see it? It's down here. And now I move the 4 over. That's vertex form. What's my vertex? Negative 2, negative 4. Right? Change and keep. Cool, cool, cool.
Wait, do we have to do that part?
Yep. Also says give me the vertex. It asks, will it open up wide, thin, open up down? Look at this. Well, won't it open upward, right? A is 1, it's positive, so it's going to open up. Is it going to be wider than a regular parabola? Or is it going to be thinner, or is it going to be the same as a regular parabola? Regular parabola meaning this.
Wider.
Don't they both have A equals 1? So it's going to be the same width, right? Same width. So it's just like this parabola, but it's just moved over a little, right? Its vertex is shifted. That's it. Yeah.
Can you explain why, like,
Why do you have -2 instead of positive?
So -2 when you plug it in is what gets you 0, right? 0 squared is 0, and we get -4. See how -2 gets me -4? So it's going to be the opposite sign.
y means equal 4, right?
Right. Well, right, exactly, yeah. So the vertex, this is vertex form. Remember, it's this guy, h and k. Remember h and k?
Yeah.
And the formula is minus h and plus k. So we change the sign here, and we don't change the sign there.
So half them is plus 4, it just be regular.
It'll still be plus 4. Yeah. This one's the one that changes. Yeah.
For x, if you use -2, because you get y to equal -4.
Exactly, right. Mm-hmm. Yep. Yep. That's pretty much why it is the way it is, Jace. Yep. So it'll open up, right, because positive A, right, 1 in front of here. And it's going to be the same width as a regular parabola, right, because that also has A equals 1. This one, same dumb crap, right? Do we do anything with the 1 while we're completing the square? No, we just set it off to the side, right? We cut it in half, get 3. We're going to add 3 squared to both sides. We're going to get x plus 3 quantity squared in the bottom. Moving on. 9, same dumb thing, but b is odd, so we're going to get a fraction, right? And that's okay, 3 over 2. We can deal with that. You want to do that one together? Okay. Jace. Which one?
How will we know if it's like opened up or
If A is positive, right, then it's going to open upward, right? And if it's negative, it opens down. Remember that from Desmos?
yeah.
If A is a big number, then it increases quickly, so it's going to be thin. If A is a fraction, it's going to increase slowly, so it's going to be wide. If A is 1, well, it's the same as our regular parabola, so same width. Okay? Good question. Let's look at 9. 9 has an odd number there, so it's just a little weird. We don't have an A value, so we don't need to pull anything out. We cut that rectangle in half and square it, right? What's half of 3? 3 halves. Very good. So that's our square that we have to add. Remember, we square it because it's a square. Now we have to do it to both sides, so I have to remember to add 9 over 4 here. Isn't that just 9 over 4? Right?
Yeah.
Square the top and the bottom. Right. The reason I don't write 9 over 4 here is because that tells me what goes in here. 3 halves. You see why I kept that as a square number? Because that tells me directly what goes in here. Right? 9 over 4 would not be what goes in there. Okay.
Yeah.
And now we move the 9/4 over. We need common denominators to subtract it from 2. You know how to get common denominators? So I moved it over, right? And now to put them together, how many fourths are in 2?
4.
4 fourths. What's 4 divided by 4? 1. That's how many fourths are in 1. So there are 8 fourths in 2. Right? So that's going to be negative 17 fourths on the end there. Right? I'm not writing it all again. This thing, but with negative 17 fourths on the end. All right, common denominators. That's right. Did you say cops? Cops. Someone here's a cop. Who has a wire? You're a cop, you have to tell me. All right. Yeah?
So that would open up.
Oh, yeah, I forgot about that. It opens up because A is still 1, opens up. And it's the same width, right? A is 1. Same width. Remember, if A is a fraction, it grows slowly, so it makes the parabola wide. If A is a whole number bigger than 1, like 7, it'll grow really quick, so it'll be thin, right? Tickler, you with me? Rad. Oh, yeah, the vertex. Negative 3 halves and negative 2. Change it, keep it. Oh, wait, sorry, not negative 2. Negative 17 fourths. My bad.
Do you know what's happening to your math?
No, I don't. I'm sorry.
That's chill.
I'm excited to get to the other problem. Because I like math. 10. All right, what makes 10 harder than the last couple ones we've been doing? A is not 1, it's 2. So we got to pull out A first, right? Now, even before going, I know my parabola is going to go open up, right? And is it going to be wider or thinner? Thinner, because it grows really fast. Remember, 2 grows faster, so it's going to be thinner. So it's thin. Now, to get this done, I got to pull out the 2 first, right? Do I pull it out from all the numbers? No, I just pull it out from those 2. And it'll be nice because that's an even number. So when I do that, I get y equals 2 times the quantity of x squared plus 3x minus 3. Right? I'm doing one step at a time. I swear to God, if A is not 1, do not skip steps. I know you'll want to, but don't. Yep, Jordan caught you. All right, yep.
So basically, we'll know if it's the same width than or wider if there's something in front of the x.
Yeah, that's A, right? A tells you everything about the width and which direction it opens, right? We learned that from Desmos. Right? Yeah. So now we just treat this like a regular thing, right? So we're going to complete that square. I cut the rectangle in half. What's half of 3? 3/2. And it's squared inside here. Now I have to add it to both sides, right? Isn't that 9/4?
Yes.
Right? However, don't I have to remember to multiply it by 2?
Yeah.
If I've got 9/4 and I double it, how many fourths do I have?
How many?
9/4 doubled is 18/4, right? Can you simplify? Sure, but why? But why? Ryan Reynolds.
Why not?
But why? So now we do math and we move things around, okay? I'm going to leave that for you. This becomes x plus 3/2, quantity squared, minus 3. There's still a 2 in front of there. Right? You're going to have to move that over and get commie denomies. And then you figure out your vertex. It'll be negative 3/2 something, right? What?
Nice.
11. Why is it weird? A is 3. We got to pull out a 3. Oh no, how do I pull out a 3 from 4? It's going to be 4/3, right?
Yeah.
That's it. It's all good. It's fine. And if I cut 4/3 in half, what do I have? 2/3. You can think of it that way, right? 2/3 or 4/6, right? Division's multiplication down on the bottom, right? So 4/6 or 2/3. What are we doing? They're equivalent fractions. Will it be wide or thin? Thin, because it increases quickly. Thin, and will it open up or down?
Open up.
Up, because it's positive.
So it's the bigger the number, the thinner it is?
Yeah, because it increases really quick, right? And then if it's positive, it's opening upward really quickly. If it's negative, it's opening downward really quickly, right? Right? 12, is it going to be wide or thin?
Wide.
Wider than a regular one, right? Because it's going to increase slowly, right? And is it going to open up or down? Up. If I made that negative, it would be wide and down, right?
Will ever be
Negative
down.
would open down.
Negative opens down, positive opens up. If it's a fraction, it's going to be wide. If it's a regular number, it's going to be a lot thinner than a regular one, right? Now, how do we do this one? No, we're not done with 12. We have to pull out a third, right?
Correct.
How do we do that?
By pulling out a third.
Well, for this, it'll be x squared. How do I pull out a third from x? Isn't it like division? Dividing by a third is the same thing as what? By 3, the reciprocal, right? So when we pull out a third from x, you know what happens? It becomes 3x. Isn't that wild?
Yes.
Isn't that wild?
Well, kind of.
It's like division, but when we divide by a fraction, we multiply by the reciprocal. If I gave you that tomorrow without doing today, you'd be like, that's not fair. And I'd be like, you're all a bunch of dummies. But now I give it to you.
No.
And now we do math, right? We're going to cut that in half, do the thing, right? All right, move stuff. Okay, great. Moving on. 13, baby. Demonstrate why the process of converting from standard form to vertex form is called completing the square. Guys, we already did an example like that, but I'll show you. Please include a diagram. Yeah, pretty much. Or no. It's this. What I did earlier. Jace asked me to help him understand the problem, right? Which I love. That means you really know what's going on. You're not just doing steps, right? So we're going to use a general form, okay? So we're going to start with this. We're not finding quadratic, so we don't have 0 for y. Okay. So that represents, or let's do this. Let's get rid of the a. Let's make it easy. Let's have a be 1, okay? We'll have it be easy. So doesn't this stand for x squared? That's a square of x, right? Plus a rectangle. That's x by b, or bx for the area, right? Plus c, which is just really like a line segment. Right? Isn't that what that means? Something squared, a rectangle, and then a line segment. We're adding them all up, right? It's like being a joke. A square, a rectangle, and a line walk into a bar, right? So that's what that means. So now here's what we're going to do. We're going to take that x squared, and we're going to add it to that rectangle. But what do we do to that rectangle? We cut it in half.
But not on the x-axis. Yes.
No, not on the x. We cut it across this way. We're going to cut that in half like this. Right? And split it and put it here. I know my drawing's not very good. All right, if the length was b and I cut that in half, how long is it going to be now? b over 2. That's how long it is. Now, how do I know this is x? Right, that makes sense. That's why it lays down perfectly. No matter what rectangle you have, right? It's always going to be a dimension of x. And that tells us what's left over, what we need to add, right? What are the dimensions of that square? b over 2 by b over 2, which means the area is b over 2 squared, otherwise known as b squared over 4. b squared over 4, right? We square the top and the bottom. And the reason for that is because we do b times b and 2 times 2, right? Good. So we need to add on b over 2 quantity squared. And we got to do it to both sides, right? Which I always forget to do. Don't be Mr. Mac. Right? That's why we do it. And then look, we made a perfect square here. How do I know it's a square? Because it's the same length on both sides. And what is the length of both sides? That's the length of both sides. So another way to write that, to say the whole area, would be x plus b over 2 quantity squared, right? So all of that is our square, right? And another way to write that is x plus b over 2 squared. Yay! Vertex form! Oh yeah, I forgot. Then we move over this. You can simplify that or leave it like that, I don't care. You can have it be minus b squared over 4, or you can have it just be minus the quantity of b over 2 squared. I don't care. That's fine. That's it. Guys, this is the first half with a picture of what we did on number 14. Completing the square. We just moved the c over first. Yeah, and? I added it to both sides, right? And I moved it over. I was lazy. I just moved it all over. Right? Yeah. That's it. We're done. And if you want, you can do, this is kind of like your first proof. Oh, you're going to love proofs in geometry. Swag box, that's what you get to do when the proof's done. Or you can do QED, which basically is Latin for proof in the pudding. I don't remember what QED is, like quantum edum dissertation or something. Right, I don't remember. But it stands for proof in the pudding. I like swag box. Normally you just do a square. At the end of a proof, that's just how we know you're done. That's why we box our answers. Because QED is what a lot of proofs have at the end, and it stands for qualitatum equitos I don't know. It just basically means proofs in the pudding. Right? I do double box because I'm cool. Swag box. Swag box. Yeah, I do a cube at the end of my proofs. No. How do we do this one? We complete the square, just like we just did. Then we get common denominators.
Common denominators.
And then we get x on its own. We complete the square, what we just did, but with a, right? We just leave the a. Or so help me, right? And then we get common denominators. And then we get x on its own. We complete the square. It's a hard version because it has a, right? We got to remember to have a here. It kind of makes things weird, right? But then we get common denominators, and then we get x on its own. You will be a god once you know how to do this. An algebra god. I bet most math, I don't know about math teachers here, because I don't know them super well. And I know they're really smart, so they probably do. But a lot of math teachers I've worked with know this formula and have it memorized, right? Because they need to know it to solve problems. But they have no idea where it came from or how to get it. And you guys know how to do that now. And I think that's important. I think memorization is dumb for something you're never going to use the rest of your life. Why memorize it if you're not going to use the rest of your life?
Yeah, I'm not using this at all.
Exactly. Instead, understand it, right? The difference between understanding and memorization, guys.
Listen up.
Life lesson, life lesson. I don't make you memorize crap because you're not going to use this the rest of your life. You're not going to. However, you will need to expand your brain to understand new things that you've never learned before, whether it's math, geography, whatever, right? Anything that you're doing for your job or in your life. So what we do is we do things that you're not used to seeing and get you to see things in a different way. That you use the rest of your life. The difference between memorization and learning is this. Memorization, as time goes on, what happens? You forget. Learning, as time goes on, you understand more. You get it more. The more time you spend with this, the more you're like, oh, I see it now, right? Here's an example. If I gave you these symbols and said 10 seconds to memorize it, then we're going to have a quiz, you have to copy down perfectly, right? That would be cruel and unusual. However, don't memorize, understand the concept. Everybody turn your head this way. What do you see? Z, Y, X, W, V, U, T. It's the alphabet backwards and sideways. And so if I said, okay, quiz, you get 10 seconds, erase it, I bet you could do it. You'd write it like this on your paper, and then you turn the paper sideways and in, right?
Wait, what? I don't know. That just doesn't look like an
Z, Y, X, W, V, U, T. I kind of cheated on the X, I'm going to throw you off.
That's not an
I don't like the X.
Why is it an X? It's an X. It's just a curvy one, right?
Yeah, it is.
Oh, I see it. And that H.
There we go.
Oh, yeah,
Looks like an
okay.
H. Yeah, I see it.
I get it now.
Oh, it's T. It just says it doesn't keep going.
It looks like an H at first.
Again, memorization, hard. Bunch of random crap to memorize. Understanding, oh yeah. How could it be anything else, right?
Did I get this right?
Know what it means. Memorization of this, you cut it in half, you add it in the square, and you do it both sides, and there's an A sometimes, right? That's awful. But understanding what it means, that makes sense.
Why did you say NYX? ZYX.
Z, Y, X, W, V, U.
You said NYX.
Did I? Oh, sorry.
That's what threw me off. I was like, what?
Let's see.
Wait.
I really give it away if I did this. Oh, that's how I write my Z. So, 2, Z. Delta. That's a lowercase delta. Yeah.
That's how I used to make my teeth.
I had to stop.
And my second grade teacher made her teeth like that. So
Exactly.
I
That's
was
what was so
like, oh, make my
cool.
teeth like that.
And then I taught calculus, and you like Greek symbols, and they're like, "Why is everything times 2?" And they're like, "Oh my God, that's why you bombed your last quiz." The entire class.
Now
It's
I
like, no, it's delta.
write my teeth like you.
Lowercase delta. That's uppercase.
Delta.
Yeah. Yeah. Jamba, you can keep this if you want. You study from? Okay. Review. Yeah, whatever you want to do. Guys, you can be, this can be one of the easiest quizzes or it can be one of the hardest ones. Know your crap. I think most of you guys are starting to get used to me by now. This is not an easy quiz, but I think most of you guys are like, okay, I'm seeing where this is going. Yeah.
You want your present back?
Okay, can you make sure I can do that? And then we can do that? Does that make sense? I think I understand. Red.
Lindsay,
Yeah,
please.
That is the quiz tomorrow. Get it wrong or right? Wrong.
Mine.
Looks like a lot of numbers. She doesn't even care. CJ, my mom didn't care about it.
Wait, what?
Don't forget his That's correct. And next time, actually help.
Alright, so you add these.
Don't you wish your play ones were?
Last time I thought that was a sign of anti-series. Damn, man.
Oh, you moved up to the way. Yeah, it's good.
69, nice. Yeah, why is it? Exactly. I'll let you slap me. If you have a buddy that's really getting this, you should study with them. Make up equations. You know what makes an easy quadratic, right? B being even, right? If you want to make it hard, make it odd. If you want to make it really hard, add an A value.
Dust on these things.
Oh, just for my...
The dust, oh my god, the dust on this thing.
Okay, I'll get one easier than it. Just make sure.
My god, Mac, you gotta dust these things.
I'm gonna take your elbows.
Turn it in tomorrow, okay?
Give me your elbows.
He's like wiping the dust off.
Oh, thank you. Thank you so much. Yeah, they get really dirty.
Oh, I didn't record this?
Oh, man.
Yeah, I know. I told my buddy to get it in your live stream, but he didn't.
I didn't make it live, but I did record the class. I'll upload both videos and it'll take forever.
John, can you go over that? Look what it says at the top.